In this video, another application of the infinite integral will be discussed, and the topic is about surface area or surface area of revolution. Uh, from our previous discussion, you already know how to compute the volume of a solid formed by revolving a two-dimensional region about a fixed axis. In addition to that, we may also want to determine the area of the surface that is generated by the revolution. So aside sa volume solid, uh, we may be interested in determining the area of the surface of the solid of revolution. So for example, you have this one, line lang. Okay? If you have this line and it revolves length L and the distance x from the y-axis. Pag i-revolve na to sa y-axis, what we'll get is this one. Surface reticular cylinder. Surface lang. It's not the solid. Okay? Pag, pag circular cylinder, ang gi-revolve ba na is rectangle man. A rectangle revolved about the y-axis, what we get is a cylinder. So instead na solid ang atong concern, pwede rin na surface area. So, ang kining area sa area ni na cylinder is generated na siya by revolving this line about the y-axis. So, sa solid geometry, we call this one lateral area. Lateral area sa cylinder. How do we get the area of this, the lateral area of a cylinder? So it's very simple. All you have to do is i-cut ni mo, and then spread ni mo, stretch ni mo, you will get a rectangle. Area of a rectangle. Kaya lang. That's the area of this one. So L, and this one is circumference circle with radius equal to x. So this is length, length sa line, and circumference sa circle 2 pi x. So the area is equal to 2 pi x times L. Circumference times length sa line. So if we know the lateral area of a reticular cylinder with radius r and height of h, the lateral area is 2 pi rh. Same as this. Instead na x, r. Instead na l, h. 2 pi rh. No, so if we generalize this one, instead of a straight line, a curve, okay? Y a function of x from point A, f of A to point B, f of A, f of B. Pag i-revolve na ito siya about the y-axis, for example, what would be the surface area? Di ba? It's not simple. Considering na dili siya straight curves. Yeah. So you can just imagine ang surface area niya. So what we will do is, instead of revolving the whole arc, we will just consider a small strip, DL. Ang kinilang na strip ang atong i-revolve about Y. Okay. So, we can just consider it an incline or simply a vertical line. Pwede rasad. Para, or we can just compare this one to this one. No? Na, dili na to we can just assume this one as vertical. Okay? Very short man siya. Okay? Gamay ram kaya ni siya, ang DL. So, we can assume this one as a vertical line. So, ang distance niya dayon from y is x. So, pag revolve na to, ang makuha na to, it's differential area lang, not the total surface area. So, dA, but then dl sad, kay differential length naman sad. Pero 2 pi x ta, kay ang circumference na to, 2 pi r man, ang atong radius kay x man. So, we have this one, 2 pi x dl. So, pag integrate na ni, makuha na to ang total area. Ang dl dayon, gamiton nimo to ang length of arc. Atong square root of 1 plus, duha man to. Okay? Pwede na katong square root of 1 plus f prime x square dx or 1 plus f prime y squared dy. Depende sa limits. Oh, okay. So, you have this. Pwede ra. Ngayon? Oh, so, ang DL nga gamit yun eh. And then you integrate. Pwede ni siya o katong isa. F prime y dy niya c to d. Basta circumference times length. Okay. Sige. Let's solve a sample problem. Find the area of the surface generated by revolving y equal to x cubed from 0 to 2. X greater or equal to 0 but less than or equal to 2. About the y-axis, x-axis rather. So, y equal to x cubed is this. Of course, not dire, pero kay 0 to 2 ang limit, so we can just consider the part of the curve sa first quadrant. Half of this is nasa third quadrant. Y equal to x cubed from 0 to 2. From 0 to 2. When x is 2, y is 8. Kana. And so, i-revolve siya sa x. I-revolve siya dire. And analyze ta. Consider ta dl. And then, y siya ta. Para, ang ato circumference is 2 pi y. So, okay. Para you can select sa L, itong square root, 2 pi y mga ta. 2 pi y. So, mas better kung if you will use ko itong square root tapos dy, no? F prime y, dy. Para di na ka mag-change sa y. Like this one. Kaya because if you will use this one, katong square root of 1 plus f prime x squared dx tapos y ni, then you will replace y by x. Like this one. You replace this one by x cubed kay dx mo ka dire. Pero kung kini na expression sa L imong gamit, as is lang, y, dy mo ka. Di ba? Di mo mo ma-change. Okay. Sa x mo ka nag-revolve, therefore, circumference niya is 2 pi y. Pero kung i-revolve siya sa y-axis, mo distance, so ang circumference niya, 2 pi x. Di ba? So, you cannot change 1 to 2 pi x. Kaya sa x-axis mo ka nag-revolve. Horizontal axis ba? So, now, caution. Reminder. This is not always y, 2 pi y or 2 pi x. Depende sa axis. Like, for example, if this arc is revolved about the line y equal to negative 2, then our y sa formula or our radius will be y plus 2. That will be our radius. Kaya circumference man na, 2 pi r man sa. But since x-axis raman sa therefore, ang atong radius is y rasad. Pero kung y equal to negative 2, then our radius is y plus 2. Ano? Similarly, pag kinina i-revolve na to sa, let us say, x equal to 5. Ba? X equal to 5. Ang atong radius is this one. Ang atong x kay kini man. Mo man x man eh. Then, our radius is 5 minus x. Kay 5 man eh. Ba? Assuming ha, na x equal to 5, i-revolve. So, ang radius na to is 5 minus x. So, mo nang meaning, ano eh, circumference man eh. It should be 2 pi r. Eh, 2 pi r. Dili kay, mo sa sample good, why naman to x? No. You have to understand na radius siya ka circumference man eh. So whatever is the radius, depende sa problem, mo ibutang ni mo dari. Eh. Sige. So, let us get the first derivative of y. So, sorry. F of y man. No. F prime y is x a function of y. Sorry. X a function of y raised to 1/3. So first derivative of x or f prime y equal to this one. 1/3 times y raised to negative 2/3, or simply 1/3 y raised to 2/3. Okay, so sa y man, so ang limits na to 0 to 8. And then 2 pi y square root of 1 ini. This is f prime y squared. So square na siya. 1 over squared is 9 y raised to 4/3, and then get the LCD. Okay. And then extract nimo ang root sa denominator para numerator na lang ang radical sign. You have this one. Square root of 9 y raised to 4/3 is 3y raised to 2/3. Okay. We simplify. We combine y and y raised to 2/3. 1 is greater than 2/3. You subtract. Na sobra na 1/3 sa numerator. And you have this. No? 2/3 pi y raised to 1/3. Again, you cannot use a simple use substitution. Instead, trigonometric substitution ka. No? And tangent ta kay plus man eh. So this is our u. Our a is simply 1. So u equal to a tangent theta. Differentiate. 2/3 minus 1, negative 1/3. And then cancel. And then put y raised to 1/3 sa denominator. And then construct a triangle. Tangent is opposite over adjacent. Adjacent is 1. So opposite, adjacent, and then hypotenuse is this. And then second is hypotenuse over adjacent. So kana lang. I-replace na to. This one, square root of, this is 9y raised to 4/3 plus 1. It's second theta. Second theta ni. Ang y raised to 1/3, ang y raised to 1/3 is this. Yan eh. Oh. Pwede rasado. Si Anel lang. Sige lang. Sige. Before to mag 1/3, and it's 2 pi over 3 y raised to 1/3. Radical square root of 9 y raised to 4/3 plus 1 is simply secant theta. Our dy is this. Y raised to 1/3 over 2 secant square theta. So, ang y raised to 1/3, ma-multiply siya, ma-combine, it becomes y raised to 2/3. Na namatay y raised to 2/3 dire. Okay? Okay. Oh. Makancel ang 2 dire. And we have this. Pi over 3, we write it before the integral sign. Pi over 3, y raised to 1/3, and y raised to 1/3 is y raised to 2/3. Okay? And y raised to 2/3 is tangent theta over 3. So we have this tangent theta over 3. Secant and secant squared is secant cube theta. And then combine 3 sa pi over 3. This becomes pi over 9. And power of tangent, cotangent, secant, cosecant. Let u equal to secant theta du, tangent theta, secant theta, d theta. So, ang isa ka secant theta ma-include sa du. So, what remains is secant squared. So, we only have u squared du. And then integrate. You replace u by secant. And then replace secant by, ito na expression sa secant. Yan, secant theta. This one. And then substitute or evaluate from lower to upper limits. 8. 8 raised to 4/3 is 16 times 9. That's 124 plus 1. 144. 9 times 16, that's 144. Plus 1, it's 145. 1, 4. Raised to 3. And 0, so 1 lang. Square root of 1 raised to 3. Okay, so the surface area is 203.043616. Now, the alternate solution is okay, 2 pi y because we cannot change this one, 2 pi y. But then, ang dl na to, ang gigamit na to is katong dx. No? Instead na dy. So, in this case, kay dx man ta, we have to change this one to x from the equation sa curve na y equal to x cubed. So we replace y by x cubed. So y equal to x cubed. Get the first derivative, it's simply 3x squared. So x man ta, 0 to 2 ta. Ang y is 0 to 8 man. Okay, y is x cubed and then 1 plus 3x squared squared. Now we can use u substitution because the derivative of x raised to 4 is x cubed. We have this one. So let u equal to 1 plus 9x raised to 4 du. It's 36 x cubed dx. So ang x cubed dx will be part of du. And so we have this 2 pi square root of u x cubed dx is du over 36. So makanselan to pi over 18 ta. Integrate u raised to 1 half du. That's 3 halves over 3 halves. We have this. Cancelan to 18. 9 times 3, 27. Ang u na to is 1 plus 9x raised to 4. So, we evaluate 2. 2 raised to 4 is 16 times 9, 144 plus 1. And then 0, 1 lang. Okay. Same result. Okay? Same result. Okay, whether ang gamito nimo is this one, kini, dx or dy, same result. Okay. Magdepende na lang sa uh, succeeding steps. Like sa katong dy, na result ka trigonometric substitution and also power sa tangent secant, cotangent cosecant. Whereas this one, merely use substitution lang. And then another example, show that the lateral area of a circular cone is equal to pi r L. Okay. This is already formula sa lateral area sa circular cone. So, if we consider this cone, okay, this cone, ang cone is a solid of revolution when a right triangle, this one, right triangle is revolved about the y-axis. Cone ito makuha. Pero if you consider only this surface area, it's actually a line revolved about this line, revolved about the y-axis. And you, okay, suppose this is our coordinate axis. You have this line, it revolves as a y, and we get the kinina surface area. We call it lateral area because pag surface area, that includes the area of the base. So if we exclude the area of the base, we call it lateral area. So i-label na to R, radius, height sa cone is h, and this one, slant height, we call it slant height sa cone or simply L. Okay. So again, if we consider this one, DL, and revolve sa Y, so we have this distance X. Ba? So ang area na to is 2 pi x, kaya ang circumference na to, ang radius niya is x man. So 2 pi x na. Pwede dx, pwede po dy. Okay. So, but first, kuha na to ang equation sa line para makakuha ta sa derivative. So, equation sa line, standard form. One standard form is this one. Y equal to mx plus b. By-intercept, which is h. Ang slope niya rise over run. But since mo na itong line, negative ang slope ani. Rise over run. So the slope is negative h over r. And we have this one. This is our equation of the line. Negative h over r x plus y-intercept niya is h. Okay. So, ang derivative ani is kinira, negative h over r, like constant. Okay, that's our first derivative. Derivative sa y, or f prime of x. Okay, so our limit sa x is 0 to r. And then the 0 to r. So, 2 pi x lang. No need to change this one kay dx lang ta. Okay. And then, square na to. And then we get the LCD. Now, you will notice that by Pythagorean theorem, r squared plus h squared is actually L squared. Yeah? So we can replace this one by L squared. So if we extract the square root, this is simply L over R. So times pi, that's 2 pi L over R, x dx lang. 2 pi L over R, x dx. Integrate, that's x squared over 2. So, if you substitute r dire, r squared over r, this r na lang, ba? And then makancel ang 2. So, r times pi times L. The area is, cancel na, The area is pi RL. And na-prove na to na the lateral area is pi RL. Okay. Checking is it's not fun. Ang checking ani is dili by integration. We have this Pappos theorem. We have this one. 2 pi x times L dihapon using Pappos theorem. Wherein ang x ani is ang centroid sa line. Centroid centroid sa line. So, since we have a straight line then ang centroid niya will be at the center. Geometric center niya sa nastunga again, no? Straight line man eh. So, nadir ang centroid. Nadir ang centroid. No? Kana. Okay. So, considering this whole length L, nadir ang centroid. Kaning x na to, distance ni siya sa centroid going to the axis. So, kanina distance, centroid to the y-axis. So, by ratio and proportion, since naan siya tunga, and R ni siya, therefore, R over 2 ni siya. Okay, by ratio and proportion. Oh, bali. L ni siya, L. So, L over 2, L over 2. Pag R ni, R over 2 sa ni. So, kung H ni, H over 2 sa ni. H over 2. So, this R over 2 is substitute na ito dire. Makancel ang 2 and we have pi RL. Ang kuha ni, this one is Pappos theorem. Okay. Muna atong checking. And this one is using integration. So again, in computing for the lateral area, wala kay choice sa circumference. It's either 2 pi, basta 2 pi r. 2 pi r. So all you have to do is find the radius or the distance of the differential element dl, ang yung distance niya paingon sa axis. Whether it's x or y or x plus a certain distance or y plus a certain distance. Depende lang sa problem. Basta always remember na radius ya. Radius. So that's it. So I hope that you have learned something sa discussion. Thank you for watching.